So today I'm going to talk to you about engineering a scalable knowledge graph builder on Neo4j Cloud, and hopefully sort of tell you what Neo4j is and what a knowledge graph is and what all those other words mean as well. And so to introduce myself, I built a graph, obviously. So what connection do I have to this building? So I actually studied at Newcastle University and I did a statistics PhD. Currently, I'm obviously working at Neo4j, and also I love functional programming. And again, I'm going to just talk about Neo4j, knowledge graphs, and then our new feature, which is called document intelligence. Document intelligence being turning your unstructured data into a structured knowledge graph, which can be used in Neo4j. And then I'm going to focus a little bit on something a bit more general with some motivation as to why I'm focusing on this as well, which is how we balancing experimentation and production requirements. So obviously I started the morning by asking the LLM about myself. And this is kind of the 2026 version of Googling yourself. It's like a vanity search. But my LLM is pretty dumb. I don't know whether you remember this from the early days of language models. It has a knowledge cutoff. So what do? Nowadays we have MCP, we have tool calling, and we have RAG. But sometimes it needs a bit of prompting. And we've all been here. We put our first prompt in. Mine is usually just copy and pasting an error and then typing a question mark and hoping for the best. But then you realize that it hasn't got the right answer. So you just give it another try. Okay, why don't you just use vector embedding search to fetch some additional context? All right, okay. I realize I have relevant document in my knowledge base. Let me fetch it for the user and augment my response. Okay, so now it's said, okay, the 2026 AI in Production Conference will be hosted in Newcastle. Well, still hasn't figured out. That's me. All right, so what if we had additional context for these documents? And here's a really simple graph schema. We have some nodes inside of it: person, company, conference, city, and we have some relationships between them. And graph RAG is kind of just like RAG, but we get this additional graph context. We understand how these entities are related. We can extract entities from the documents and we can traverse it. And because we're Neo4j, we're the world's leading graph database, we're able to provide that really high-level production-ready graph for you to query. So now we ask our question again. This time, the thinking can use this tool call, which is our text-to-cipher model. Cipher is our standards-abiding graph query language. Now, because we've got a knowledge graph with that information in, we can craft that cipher query and we can get the right answer from the graph. And so that return type will be sent back to the LLM. And the LLM can give you a response which is grounded in the truth, similar to normal RAG, but this time you have additional context from the graph. And this is all well and good. We can sort of avoid hallucinations, but the challenging part now is building that knowledge graph. And so obviously now you're an expert in Neo4j, you're a knowledge graph evangelist. And for any of my evangelists, I've got some stickers down here at the front. And let's just dive in to how we built this production-ready knowledge graph builder for our customers. So we have sort of typical requirements for a production application. We have some like non-functional requirements, like has to be compliant, has to be secure, et cetera, et cetera. And Neo4j is a really complex system. We're actually deployed across 3 major clouds. So we lean heavily into open source so that we're kind of cloud agnostic. So I've heard a lot of times people are talking about maybe Google, Vertex AI and things like that in the word nerds talk, but we're across AWS, GCP and Azure, and that's for compliance reasons. Some of our customers don't want data to leave certain regions. They don't want data to leave certain clouds, and we meet them where they're at. But then we have an additional requirement for an application that incorporates AI. And the problem is that you can kind of do everything right, and it's still wrong for someone. And it's so frustrating. And so our challenge is to build this scalable and high quality knowledge graph builder, which also has these other non-functional requirements. And then because we're a database and a privacy-focused database, we have this additional constraint, which is really, really tough for building traditional models. We can't look at the customer's data. The customer's data is their data. We only process it to deliver them a database. Obviously, we could ask them to opt in, but that's a lot more complex with legal, and they don't necessarily want us just diving around in customer data. So that gives us another requirement. We want to build something that's really flexible and which can suit the customer's needs. And so what does the graph builder look like? Hopefully that's the right size. And it's kind of like an ETL pipeline. We read in some data from somewhere, like a bucket or some local files. We pass it into some chunks. And so those documents could be anything. They could be PDFs, they could be CSVs, it could be JSON, Markdown, whatever it is. We need to pass it into something suitable to pass to the LLM. So there might be OCR involved. There might even be an LLM involved in this step to do some understanding of the documents, like we've seen in the last session. And after that, we perform this entity extraction. And so that is typically an LLM, but there's still multiple ways to do that. Which model do we choose? Which prompt do we use? How many times do we put it through the prompt? Do we put a human in the loop, et cetera, et cetera? Then we resolve those entities. So if we're processing multiple documents separately, I might have a person, it's Jonny Law from document 1, Jonny Law from document 100. We want to merge those entities before they get entered into the graph. And our output at the end is just some structured data. And then we have a normal importer, a structured data importer. So in reality, this is just some Parquet. And after that, we can hand it over to our regular importer. And so I mentioned at the start, yes, absolutely, yeah. So when we do entity extraction, that's entity and relationship extraction. And we can also resolve relationships as well. So it's kind of entity and relationship resolution. And so I mentioned functional programming at the start, and it wouldn't be an engineering talk without showing a little snippet of some code. And so our pipeline kind of looks like something that you might see in Spark or Flink. These are like traditional big data pipelines. And one thing that we get from this is that it's a nice chain of higher order functions, which brings the data to the forefront. And when I introduced this architecture, I'm a little bit biased, but when I started, we had a lot of execution details within stages. And that meant that execution was a little bit unpredictable and things that were actually difficult to do because it's a graph and we're doing complex mutations on the graph were even harder because we had execution details mixed in with how do we make this parallel? How do we send concurrent requests? How do we wait for those requests, et cetera, et cetera? Well, this brings all that execution logic to the top level and unifies it. And it's super nice. And it means that we can parallelize exactly where we want. And actually it makes it easier to test these individual stages. Because for instance, parse document, it only cares about parsing one document. It doesn't care about parsing n documents in parallel. Map does that for you. And so I mentioned we wanted to close the gap between experimentation and production. And the idea for that is enabling rapid iteration and experimentation. We want to do as many iterations and experiments as we can. And I mentioned there's lots of different ways to plug in those stages. And that's what our researchers are working on. What different types of parsers can we use? What different types of prompts can we use? What's the impact of Google discontinuing Flash 2.0 and now we have to use Flash 2.5? And to do that, one of the things we've done is to focus on developer experience. I think developer experience is so important. And we want to make it easy to experiment using the production workflow. We want to ship the same code to production as we ship to our evaluation cloud, as we run on our local machine. And so for development speed, we use something called Mies. And this is a tool which can automatically install all of your developer tooling. And we use K3D because we use Kubernetes in production. A K3D is a lightweight Kubernetes that we run locally. So you can test your orchestration works from your local machine. We've got big, beefy M4 MacBooks with 128 gig of RAM or whatever it is. These are absolutely ginormous. These could have been supercomputers years ago. Our workflow, like I said before, is written once and can be deployed to multiple environments. And the idea here is that when our researchers are implementing a new parser or a different type of extraction phase, they can write that once, they can run it on their local machine, make some tweaks, they can put it up to the evaluation cloud, evaluate it on large-scale data sets, and then ship that to production with exactly the same code. And how do we sort of provide that? Well, one thing we leaned into was configuration-driven pipelines. And you've seen it's a chain of higher order functions, and it's actually orchestrated by something called Argo workflows. Not that that's that important, to be honest. But the idea is that each of these steps, so the embedder, the entity extractor, etc., these can be configured. And this is just in YAML here. Essentially, every stage in that pipeline has like a fixed API, but we have loads of different choices on how to implement them. So our embedder provider here is Vertex, but it could just as easily be OpenAI or whatever the customer prefers. And we can also overwrite that configuration with MVARs. And this is just a complete industry standard. We don't have to rebuild the Docker container, and we can just immediately overwrite something. You know, if we made a regression, we could change that value without rebuilding. Exactly. So we want to ensure that quality is high through some sort of experimentation. And I'm going to talk a little bit about offline experimentation. And again, we don't have access to the customer data, so we can't directly validate the quality of their generated knowledge graphs. But we do have some selected data sets from our friends in industry, and we also create some ground truth schemas and have LLM judges and things like that to assess quality of generated graphs. But one thing that was missing when I joined the company, so I joined in September last year, was actually a platform for doing this reproducible experimentation. So when I joined, I would see a lot of brilliant researchers delivering things on sort of Google Slides or Google Docs or whatever, and they might have scripts inside of Python notebooks, and they had deployment scripts that they would run from their laptop that would deploy on RunPod or maybe Google Cloud or something like that. But it wasn't very reproducible. So I said, let's make a platform to make this reproducible. And we called it the Gen AI Cloud because we're the Gen AI team within Neo4j. And right now it's used across my team, which is the Knowledge Graph Builder, the agents team, and our text decipher team. And the idea is just to evaluate and improve the quality of our models in production. And when we were building this, we have a really wide choice of tools to build a platform. We're primarily Google Cloud, even though we work across AWS and Azure. Google Cloud is sort of our default cloud. So we focused on anything that was managed. Me and one other guy built this, Claude. This other guy called Jelko, and then Claude. And we leaned heavily into managed services, right? We're not DevOps guys. My background's in research. Jelko's background was also in research. He was a professor before he came to Neo. And so our stack was primarily Google, but then the sort of production realities hit us a little bit. And because we have this multi-cloud deployment in Neo4j, we decided to use a bit of open source to bridge the gap. What we did was, because we're using Argo workflows in production, we went, well, we need an orchestrator in Google Cloud. So Google Cloud provides a few orchestrators. The biggest one that you guys might have heard of is Airflow, Google Cloud Composer. But we chose Argo workflows, so it would be exactly the same as production. And then talking to the researchers, if they want to have their stuff running in production, well, learn this first. You can't go wrong, and you'll understand how it works in production as well. Obviously, we built all this using infrastructure as code. And one of the things that we chose to do was have this sort of sandbox project, which is a pre-release project, we called it. And then we have a release project as well. And what that allowed us to do is build out all of the infrastructure as modules and then deploy it twice to two different projects. And then they're completely separate. And we can't get any like weird leakages between the two. You know, we kind of let people mess up the pre-release project and then just delete everything. But we have closer control on the release project, where something like only GitHub Actions can send a workflow up to Argo, whereas on pre-release you can just build a Docker and submit it, and we don't care. But yeah, we don't like that when we're thinking about our production models. And to support that, we built a custom workflow submission CLI, and this is just in case we maybe switch the orchestrator. Lots of things change in production, but we didn't want the developer experience of our researchers to change much. So we built like a nice CLI that allows people to really quickly and easily submit their workflows. And you can see it sort of looping there. We also have custom experiment tracking. Initially, we chose Vertex AI experiments. I had some experience with Vertex AI experiments. It's kind of rubbish. It is what it is. It kind of just provides you a table with some numbers in it and maybe some artifacts if you're lucky. What we did is provided this really lightweight library, which was just a little facade over the top of a tracker, because we kind of knew that we wanted a better tracker, but we also didn't want to make the researchers, again, write things for a second time. So this just allows you can see in the right-hand side, create tracker. You can just change the tracker type in there, and that will automatically change everything through it. And so yeah, exactly. So we can change the tracking code without making large code changes, which is super, super nice. And this is the final result. So this is our knowledge graph builder. Obviously, I upload my favorite Bayesian model comparison paper. And then the first step is something that I haven't actually mentioned, but this is the schema extractor. And this builds a schema of your graph. It does a quite heavy sampling right now. So because we're still sort of exploring the market of where this fits, we wanted to be really responsive and like kind of cool to show in a demo. And then after that, we can import it straight into a Neo4j instance. So I think this is my free instance on on Google Cloud. I edited this video myself, which is why it's so janky. And there we go. And then I just click, I think I'm clicking explore. I don't really know how to use the Neo4j database, to be honest, but it's built me a graph, and now I'm on Graph Explore, and I can see all of my nodes in a nice little UI, some of the authors of the papers as different entities. And then it's just back to the beginning. And that's kind of all I had time for. And the idea, what I want you to sort of take away from this as well is we had this contention between the researchers running really, really fast to build these new features, and the product people getting so excited that the researchers are showing them these new things that are so accurate or producing these fantastic knowledge graphs. But there was nothing in production. When I started in September, there was absolutely nothing. I noticed this gap where we really needed something systematic that allowed us to experiment, rapidly and bring those things to production. And it would be remiss of me to not mention that we've got an open source package for this. So Neo4j is very open source friendly. One of the things that we should be focusing on, I'm not in product, so I don't know when, but we should be focusing on a self-hosted version of this. But until then, you do have the Python package, Neo4j GraphRag Python, which you can explore. Are we done?